Hey everyone, this is the review for the test. Going to go over a few problems on the packet, and here we go. I'm not good at intros. So, first thing is don't do numbers 4 and 5. I got excited about calculus like I do, and I thought we could handle what is a trickier concept, which is being able to see what the derivative of a graph is supposed to look like. Don't do it. Skip those. Don't worry about that concept. We'll get to it when we need to. So let's go over number 1. These are quick, these graphs that are there. Um, think about the concept of velocity, acceleration, position, and how they're related. Remember that think of position as the thing that you start with, all right? S of t. Position is dependent on time. I'm driving at a certain speed, right? If I'm in a car, right, and my position is just where I am, S, right? In a different way of thinking, my velocity, the speed at which I'm moving, is v, which is the derivative of s. You might say s dot of t or d dt, okay? That is the derivative of s. And then the rate at which even this is changing. I gave the analogy that velocity you could think of as cruise control. You're moving, but if you're moving at a constant velocity, all you can talk about is velocity at that point and position. But once that starts to change and I can feel that push back into my seat when I hit the gas, that's acceleration. Okay? So these are the concepts, and they are just more. Acceleration is the second derivative of position, d2 of s, or you could say it's the derivative of velocity. All right. So use the figure to answer the question, when is the body's acceleration equal to 0? So if acceleration is the derivative of velocity, a is equal to d, the derivative of velocity, the rate of change of velocity with respect to time, then when is my velocity not changing is the question. When is there no change? And it's when my slopes are 0. So the slopes, there's no change between these 2 points in my velocity, right? Time is going by. This is time passing in this direction. And my velocity is the same the whole time. So it would be A, from 2 to 3 seconds, and make sure you put an interval from 2 to 3 seconds. It's not a point. We might be tempted to put here B, but it's not B. 2 to 3 seconds and 5 to 6 seconds, okay? So velocity is the slope or the rate of change of, acceleration is the slope or rate of change of velocity, and since the slopes are 0, the acceleration is 0. There. Don't want to say more than necessary about that. Where is the function differentiable? Differentiability of a function means you can take the derivative. But what that really means is that the derivative exists at every point, because to take the derivative of a function means that at every point the function, the slope doesn't change suddenly. There's no sharp points, right? That's what we want to think about. For graphs, there's no sharp points. It's smooth. So that's our sharp point. But when we talk about sharp points, we don't care about the y value. Usually when you talk about functions and where is it differentiable, where is it continuous, where is it, where does it have an asymptote maybe, or stuff like that, you only care about the domain, which means I only care about the x values. So the function, the values for which it's not differentiable must be x values. And the x value here is not 1, it is 0. So that's my answer. Okay? So move on. Here, the x value here is not 3. Where's the function differentiable? It's not at 3, it's -2. It is not differentiable. And at 2, it is not differentiable. So -2 and 2. Okay? Not differentiable, right? Okay, so we're skipping 4, and we're skipping 5. Alright? And then we're going to do 6. So 6 says, this one I'm going to have to write out. 6 says, given the distance function, find the velocity function and the acceleration function. So again, like I just said, that if I have s, which which is usually what they give me, this is telling me how this particle is changing its location, right? And I can plug in time in seconds to figure that out. But if I wanted to find out how quickly is it changing its location, velocity, right? That is the derivative of this, which is 2t plus 4. And this tells me the rate of change at every point. If I wanted to even find out how quickly is the velocity changing, then I would take the derivative again. The acceleration is the derivative of velocity, which is the second derivative of position, which is just 2. Okay? So these are my two things in my answer, which 2t plus 4 and 2, 2t plus 4 and 2, looks like it's D. Okay? A ball is dropped from the top of a building, has a height of this meters after t seconds. How long does it take the ball to reach the ground? So in class I said that you have a building and you drop a ball, and this is the path of the ball, right? So I want to know, well, how long does it take to get there? Well, thankfully I have this equation right here to tell me that, all right? Or when will it get to that point, to this height right here? That's what tells me that. Now, how long does it take to get to the ground? Well, if it's on the ground, then my s is equal to 0. So s, which is this, is equal to 0. And if I solve for t, I get my answer. And I think we decided that it ended up being, I think, 3 seconds. Let me see. So it's going to be 16. T is equal to the square root of 144 over 16, which is 12 over 4, which is 3. So it's 3. Okay, they even make the numbers nice for you. Okay, we did these in class. They're really good questions. So I will do one again. Okay, I'll do the first one. So find the equation for the tangent line at the given point. Number 8. Y is equal to x cubed minus 5 over 6x, right? And then x equals 1. So the equation for the tangent line, think y minus y0 is equal to m times x minus x0, right? Point slope form. Well, this guy right here is going to come from y prime evaluated at a certain point, in this case 1. My slope of this curve at that particular x value is given by this, okay? So I have to find y prime. So y prime is equal to, this is my u, this is my v. It's going to be 3x squared minus 3x squared, sorry, just that, times 6x minus 6 times x cubed minus 5, all over 6x cubed, which is 36x. 6x squared, which is 36x squared, when I square the whole bottom. So remember, it's u prime v minus v prime u over v squared. This is one of those times when you just want to plug in your x values, right? Fortunately, y prime is by itself, so I just plug in 1, and I get here, this is just 1, 1, so 3 times 6 is 18, minus, this ends up being 1 minus 5, which is negative 4, so this is negative 24. Negative negative makes a positive, over 36, so this is 42 over 36, which turns out to be something. 2 is going to be 21 over 18. 3 would be 42 divided by 36. 7 over 6. I'm ashamed. Alright, so this is my slope for this, right? This is the big equation that we need to build here. And we get the pieces of it from the derivative. And now, do we know this? X0? Indeed, we do. This is my x0 right here. Do we know y0? We do not, but we can find it if I select a specific x. So y0 is found from plugging in 1, right? So negative 4 over 6 is negative 2/3. There's my x, 0. So finally, we can say my line is going to look like this. Y plus 2/3 is equal to m, 7 over 6 times x minus 1. Okay? Solve for y, we get y is equal to 7 over 6x minus 7 over 6 plus 2/3, minus 2/3 rather, which is 7 over 6x minus 11 over 6. Okay, so that looks like B. Alright, so now I'm going to extend this question a little further because I forgot to put a normal line problem on here, but we should be used to that because there's only one little thing that we have to do to get the normal line at this point. So the slope of the normal line is going to be negative 1 over the slope of the tangent line. And the slope of the tangent line was 7 over 6. Right here. Okay? So all I do is I flip it and make it negative. So this is negative 6 over 7. And then I already have everything else I need, right? So I have my 1, I have my 2/3, so I just plug in. Y minus 2/3 is equal to negative 6 over 7 times x minus 1. Alright, and then I solve for y. Negative 6 over 7x plus 6 over 7 plus 2/3. What is this magic? Hold on a second. Minus 2/3. Sorry, this should have been a plus here. And this is a minus. Okay. So now getting a common denominator is a little bit more work. It's going to be 21. So this is going to be plus 18. And then minus 14. So it's going to be 4 over 21. Okay. So that would be the equation of my normal line, right? Y, I'll call it norm. So just to give a little concept here for a moment, if my curve looks something like this, and I'm talking about 1 comma negative 2/3, so that looks like some, yeah, this is the, okay, I gotta think before I do things. The curve would have to go through that point, so let's say it went down here. 1 negative 2/3. I want the slope of my normal line, right? That's my normal line there, which I'm really not thinking straight here because this is actually a positive slope. So this would not be the normal line. But the point is that the normal line is going to go, I'm sorry, the tangent line, goodness. The tangent line is going to touch the graph at one point like that, but not go through the graph. Okay, that's the idea of tangent. It doesn't go through the graph, it just touches the graph. The normal line is perpendicular to the tangent line, which is going to be this that I draw, and actually cuts through the graph. Okay, they are 90 degrees. So this is my normal line, and this is my tangent line. Okay, it's not necessarily this function. Great. Number 10. Use the figure to answer the question, when does the body reverse direction? Think of velocity as speed with direction. Okay, if I'm driving a car, my speed is whatever it says in the speedometer, but my velocity is that speed along with whatever direction am I going, north, south, east, west, right? So that's why velocity can be negative. Speed can't be negative, that doesn't make any sense, but velocity can. So when does it change direction? Well, when does it go from negative to positive? Right here. Alright, so up until this point, he's slowly going backwards, then he's not moving, then he's still going backwards, and then he changes direction and starts going forwards, right? Stops moving here. So it's a little counterintuitive, but if you think about that concept that the velocity has a direction, and so the change from negative to positive is a change in direction, or from positive to negative. The graph crossed again over here somewhere maybe. That would be another one. So it's just at 4 seconds. See? It doesn't go below here. He just stops and starts again. Oh, I'm sorry. Yeah, he's still moving at all these points here. He's moving everywhere except here and here. Yeah, I kind of gave you a misconcept there. It's just his acceleration is zero. So you would feel force here. You would actually feel the car accelerating here, and then you'd be on cruise control here. You'd feel the car moving here, cruise control, feel it moving, stop, and then move again. And I mean, yes, okay. All right, enough of that. Where is the body's greatest velocity? Look at the graph, velocity, time. Velocity is the y-axis, so where's the y-axis at the greatest value? Right there, which is 5. 5. Okay? Just reading graphs. Skip number 12. Don't do number 12. It's not that difficult, but it's just the wording was so confusing. Not worth it. All right. The area of a circular oil spill changes with the radius. At what rate does the area change with respect to the radius when r is equal to 3? Rate. Okay, so area is equal to pi r squared. The question is, at what rate does the area change? So how quickly, as my radius of this circle expands, how does that change the actual area of the circle on the inside? Well, I take dA dr, which turns out to be 2 pi r. And then it says when the radius is 3 feet. So let me think of that as a prime, and then I'll say plug in 3. That's 2 pi times 3, which is 6 pi. Okay, so the area is changing by that much. That's how much more ground is being polluted, I guess you could say, or water is being polluted on the surface as my radius is changing. Okay, number 14 is a good one. The position of a body moving along a coordinate line at a time is s is equal to this. What with s meters and t in seconds, find the body's acceleration. So I hope your guess is that we would take the derivative twice, because velocity is the first derivative and then acceleration is the change in velocity. So we get s is equal to 9 plus 4t 3 halves. This represents my position. First derivative is chain rule. 3 halves times 9 plus 4t to the 1 half times t times 4, right? Reduce this, make it look nicer. We get 6 times 9 plus 4t to the 1 half. How nice of them to give us a fractional exponent right off the bat. They could have made this look a lot worse. All right, now we don't need this. We need velocity. We need acceleration. So I'm going to take the second derivative. All right, so this becomes 3 times 9 plus 4t to the negative 1 half times 4, which ends up being 12 over the square root of 9 plus 4t when I simplify it. 3 times 4 gives me 12. And then I move this to the bottom, and that's what I get. Okay? It says, find the body's acceleration when t is equal to 4 seconds. So I plug in 4, and I get 12 over the square root of 9 plus 4 times 4, which is very nicely 12 over the square root of 25, which is 12 over 5. Okay? So that is A. All right, how about, let's see, number 15, average rate of change. F of x is equal to x squared plus 2x. So average rate of change means I'm not taking a derivative. It means I'm given an interval, right? So this is some sort of a parabola here that maybe looks like, I don't know, this. And I want to know what is the average rate of change between these two x values, right? So instantaneous is always right at a point. That's why I talk about the tangent line. But average is over an interval. So let me draw it like that instead. So I want to know what is the line going through both of those x values, which is called the secant line. So they give me two x values. So my average rate of change, I'll put that for clarity, is f of 3y2 minus y1 over x2 minus x1, right? What's f of 3? That looks like 9 plus 6, which is 15, minus f of 2, which is 4 plus 4, which is 8, over 1, which is 7. Looks like 7 to me. Okay, how about I don't know how to do math? This is 2 and 6. I didn't even copy the problem down right. Great. So 2, 6. So this is actually 36 plus 12. And this is 6 minus 2 on the bottom. So this is 4. Alright. 36 plus 12 is 48. So 48 minus 8 looks like 40 over 4, which is 10. Sorry about that. So this is 10. Looks like D. Okay? Number 15 is D. Okay, good. Not a failure. Alright. Number 17. Same thing. Just it's using a trig function, so f of x is equal to 8 plus cosine of x, and it's on the interval 0 to pi. Average rate of change. Pi is just a number. Sometimes we think pi because it's a symbol that it's like if I'm taking the derivative d dx of x plus pi, well, what's the derivative of pi? It's 0. Okay? So let's keep that in mind. Alright, average rate of change, again, just think of slope, is f of pi minus f of 0 over pi minus 0, which turns out to be f of pi is cosine of pi is -1, so this is 7 minus, and then cosine of 0 is 1, 7 minus 9 over pi, so it looks like -2 over pi to me. Yeah, C. Yeah. Okay. All right. Keep going. Number 19. All right, I'm just doing this same idea again, but it's just e to the x, so we need to know how to work with our e's. Formula is the same. F of 0 minus f of -2. I like to do right then left. Final minus initial. All right. Then 0 minus -2. Okay. So this is all going to end up being over 2. So let's think, what is f of 0? Well, anything to the power of 0 is 1. Minus e to the -2, so we'll just write it like that, e to the -2. There's really not much more you can do with that. So it's just going to be 1 minus e to the -2 over 2. So it looks like it's just b. And they give you an approximation, so that's it right there. Because e is, it's like pi, it's an irrational number. So you can't simplify that. Number 19 is B. Yeah. Alright, number 20 is really easy. It's easier than finding the tangent line because all I got to do is find the slope of the tangent line. So what is the slope of the tangent line of this? Right at x equals 8. I just take the derivative. You always take the derivative first and then plug in. -20x plus 12. Plug in 8. So -20 times 8 is something. It's late. 160. -160 plus 12 is 148. Okay? So f prime of 8 is -148. It's D. Alright, and then let me just do this for the sake of showing you a quick trick on this stuff. F of x equals 2 over x plus 4. Keep in mind that if something looks like it might be a quotient rule, but you don't have an x on the top, take advantage of that and write the bottom as a negative exponent. and then just do the chain rule. So f prime of x is negative 2 times x plus 4 to the negative 2. All right? And then we can write this as negative 2 over x plus 4 quantity squared on the bottom. So f prime of negative 1 turns out to be negative 2 over 3 squared, which is negative 2 over 9. So the slope of my tangent line is negative 2 over 9. Looks like B. Okay. Finally, number 24. Find the instantaneous rate of change of the position function in feet at the given time. Instantaneous rate of change is just another fancy way of saying the velocity. So this is my position function. All it's saying is take the derivative and plug in 2 when you're done. So this is going to be a quotient rule. So this is my u, this is my v. 1 times 2 minus t minus 1 times t plus 2 all over t squared. Okay. So if I simplify this, distribute the negative, I get negative 2 over t squared. So this is my f prime of t. F prime of 2 is negative 2 over 4, which is negative 1/2. So it looks like A. Okay. All right, this is a fun question. We might as well do 25. The equation for free fall at the surface of planet X is this, with t in seconds. Assume that a rock is dropped from the top of a 600-meter cliff. Find the speed of the rock at 5 seconds. Okay, so they give you s, speed of the rock. Okay, velocity isn't quite the same as speed, but when you're given just functions like this or equations, think of them as almost the same. So I'm going to take the derivative of this. So s prime of t is equal to 5.42 t. Okay, at 5 seconds, so s prime of 5 is equal to 27.1. So this is meters per second, which is this. Okay? All right, good luck studying. Let me know if you have any questions.